A single, unexplained signal from deep space can rewrite our understanding of the cosmos. We are about to investigate 25 of the most baffling signals ever detected, all emanating from the dark, cold clouds that drift between the stars. You will discover a catalogue of cosmic mysteries that defy every scientific explanation. Some pulses repeat with an impossible rhythm, while others carry patterns that look almost deliberate. Together, these signals challenge our fundamental knowledge of physics and what might be possible out there in the void. Which of these cosmic whispers do you think holds the biggest secret? It came from the direction of a vast, cold cloud of gas and dust near the constellation Sagittarius. In the late 1980s, a radio telescope in Australia, one tasked with mapping the quiet whispers of the cosmos, picked up a burst of energy so intense it saturated its receivers. The signal appeared at a frequency of 1,430 MHz, a channel scientists guard fiercely because it is supposed to be silent, reserved for the faint emissions of deep space hydrogen. This was not a faint emission. It was a scream in a library. For 72 seconds, it blazed with a power that dwarfed the background noise of the universe, and then it vanished, never to be heard again. Its intensity and its solitary nature are what make it so profoundly baffling. There is no known natural process that can create such a powerful, narrowband, and one-time pulse. This anomaly shares a haunting family resemblance to the most famous signal of all, the WOW signal detected in 1977. Both were incredibly strong, both were never repeated, and both originated from regions of space filled with the raw material for star formation. The WOW signal's cousin, however, adds another layer to the mystery. It did not just come from empty space, but from within a specific, identifiable interstellar nursery, a place we understand reasonably well. And yet, from within that well-mapped cloud, something sent a signal that defies every explanation we have. It forces us to ask a deeply unsettling question. Was this a natural event we simply do not yet understand, or was it something else entirely? A deliberate broadcast from a cosmic neighbor whose technology operates on principles we can scarcely comprehend. That solitary scream from the Sagittarius cloud presents scientists with a beautiful and maddening puzzle. The primary challenge lies in classifying it, in deciding whether it was a freak of nature or a product of something else. On one hand, the natural explanations are numerous. Perhaps it was an incredibly powerful, never-before-seen maser, a natural laser that amplifies radio waves. Imagine a cloud of molecules like water or methanol acting as a cosmic amplifier, focusing a random burst of energy into a narrow, intense beam. Or maybe it was a pulsar glitch, a sudden change in the spin of a super-dense dead star, releasing a colossal burst of energy. Yet, each of these ideas runs into a wall. The signal was too clean, too focused on a single frequency, and most damningly, it has never been seen again. A pulsar, even with a glitch, would keep pulsing, leaving a trace. This one did not. So how do astronomers tell the difference? They look for patterns. A natural signal often has a fingerprint, a telltale sign of its origin, like a drift in frequency caused by the Doppler effect as an object moves, or a broadening of the signal caused by turbulent gas. This signal was unnervingly pure. The more speculative and far more thrilling possibility is that its purity was by design. A technological civilization might use a narrowband signal precisely because it is efficient for communication, a clear beacon shouting into the darkness that stands out against the natural radio hiss of the universe. This is the core of the debate that still rages today. Is this a signature of a physics we have not yet discovered, or is it the signature of a technology we have not yet met? The answer, for now, remains locked within that 72-second burst, a single, perfect note held in the vast silence. That singular, perfect note from the void is not the only anomaly to emerge from these cosmic nurseries. Far from the silent enigma of Sagittarius, another type of signal presents the opposite puzzle, one defined not by its silence but by its relentless, brilliant chatter. This is the mystery of the methanol maser. A maser is nature's version of a laser, but for microwaves instead of light. Imagine a cloud of methanol molecules, the same type of alcohol found here on Earth, floating in the cold depths of a stellar nursery. When this cloud is energized by the intense radiation from a newborn star, the molecules can act like a cosmic amplifier. They become excited and then, in a coordinated cascade, release that stored energy as an intensely focused beam of radio waves. This is a perfectly natural process, and astronomers observe methanol masers frequently in regions where massive stars are being born. They serve as brilliant beacons, pinpointing the locations of cosmic construction sites. But then there are the outliers, the masers that break all the rules. Some of these signals are so powerful and so persistent that they defy every model of how such natural amplifiers should work. The energy required to power them seems to exceed what a young, collapsing star should be able to provide. It is as if you plugged a simple nightlight into a wall socket and it lit up an entire city. The known physics of how gas collapses to form a star cannot easily account for such an intense and sustained output. This forces scientists to consider extraordinary possibilities. Is there an unknown source of energy within these clouds, something far more powerful than a protostar that is pumping the maser? Could it be the influence of a hidden object like a black hole or a neutron star whose fierce gravity is stirring the cloud and supercharging it? Or does this overachieving maser hint at a flaw in our fundamental understanding of how energy moves through these vast, dark reservoirs of gas and dust? These are not just quiet whispers, these are brilliant, unwavering sirens in the night, and their very existence shouts that our map of cosmic physics is still missing some very important landmarks. While brilliant masers shout their presence, other signals from the dark speak in a patient, repeating whisper. Deep within the Orion molecular cloud, a stellar nursery visible to the naked eye, astronomers detected a faint radio pulse that refused to disappear. Unlike the one-time scream from Sagittarius, this signal from Orion returns with a quiet, persistent rhythm. Its cadence is not the perfect clockwork of a pulsar, but something far more erratic, a pattern that repeats just enough to be unmistakably real, yet not enough to be easily predicted. This repetition is the key that shatters many simple explanations. A single burst could be written off as a catastrophic, one-time event, like the final collapse of a star or a random collision. But a signal that comes back again and again tells us that the source is stable. It is not destroying itself. Something is causing this emission to recur, and it is happening deep inside a cloud of gas and dust so thick it blocks visible light. So what could possibly be hiding in there, tapping out this faint message? One compelling theory points to a hidden planetary system in its earliest, most violent stage of formation. Picture a young, fiery star still swaddled in its natal cloud, with a family of newborn planets swirling around it. As these colossal worlds coalesce, their immense gravitational fields can interact with the star's magnetic field in chaotic ways. These interactions can generate enormous, repeating bursts of radio energy, a celestial tantrum from an infant solar system. Another possibility is a stellar remnant like a neutron star, but one behaving in a way we have never seen. Perhaps it is a pulsar that is partially obscured, its beam only occasionally sweeping past Earth as it wobbles through the thick cloud. Or maybe it is an entirely new class of object, something that flickers on and off due to processes we have not yet discovered. The repeating whisper from Orion does not give up its secrets easily. It simply persists, a gentle but insistent tap on the shoulder of humanity, reminding us that even in our most familiar cosmic neighborhoods, profound mysteries are still waiting in the dark. But the universe's playbook seems to have missing pages. A signal was once recorded that, according to everything we know, should never have reached our telescopes. It arrived at a very specific low frequency, a band of the radio spectrum that astrophysicists call the forested region. This is not a tranquil name. It implies a dense, tangled wilderness. At these frequencies, the sparse atoms of hydrogen that fill the space between stars become a thick, absorptive fog. They should scatter and swallow this kind of radiation long before it could travel the vast distances from an interstellar cloud to Earth. It is like trying to see the beam of a distant lighthouse through a torrential downpour. The light should be completely extinguished. Yet this signal pierced the cosmic fog with impossible clarity. Its very existence is a direct challenge to our models of how light travels through the galaxy. How could it have survived the journey? One radical possibility is that our understanding of the interstellar medium itself is fundamentally incomplete. We model these gas clouds as diffuse, uniform veils, but what if their structure is far more complex? Perhaps there are strange, clear tunnels or magnetic filaments woven through the clouds that can act as waveguides, funneling these specific frequencies over incredible distances with minimal loss, like sound traveling clearly through a pipe. Another, even more mind-bending idea involves the very nature of the signal. Could it have been transformed during its journey? Some theoretical physicists speculate about a process called photon-photon scattering, where the signal interacts with other forms of energy in a way that subtly shifts its properties, allowing it to cheat the absorption that should have doomed it. This is not just a curious anomaly, it is a potential key. If we can understand how this signal defied the laws of propagation, we might have to redraw our maps of the galaxy's structure. We would be learning that space is not an empty, passive void, but an active and structured medium, full of hidden pathways and lenses we are only just beginning to perceive. This single, impossible signal hints that the cosmos is far more intricate and wired together than we ever suspected. The hydrogen line is the universal heartbeat of the cosmos. For decades, astronomers have listened to its quiet, predictable rhythm, a constant whisper at a wavelength of 21 centimeters emitted by the vast clouds of neutral hydrogen that drift between the stars. It is a foundational tool, a beacon we use to map the structure and motion of our galaxy. But sometimes the heartbeat skips. In one particular interstellar cloud, the hydrogen signal did not behave as expected. It arrived with the right frequency, but its profile was all wrong. Its intensity far too strong for the amount of gas we knew was there. It was like hearing a single violin playing with the power of an entire orchestra. This was not a foreign signal intruding on the hydrogen line. This was the hydrogen line itself, somehow broken, somehow amplified beyond all reason. The most straightforward explanation points to something hidden within the cloud, a compact object with a fierce gravitational pull. A black hole or a neutron star invisible to our telescopes could be lurking there. Its intense gravity would squeeze the surrounding cloud, packing the hydrogen atoms into a denser, more energetic state. This would not only amplify their natural emission, but could also distort the signal's profile, creating the strange signature we observed. Yet another possibility reaches into the quantum realm. The 21-centimeter line is produced by a hyperfine transition, a delicate quantum flip within the atom itself. What if some unknown process within the cloud was influencing this fundamental dance? Could an exotic form of energy or a previously unseen interaction between dark matter and regular matter be causing the hydrogen atoms to emit their signature light in a way that defies our quantum textbooks? This anomaly strikes at the very core of how we understand the universe. It uses our most trusted map, the hydrogen line, to show us that the map itself might be incomplete. Is a hidden monster stirring the cosmic waters, or are we witnessing the subtle hand of a physics we have not yet written? The answer is written in the distorted pulse of the most common element in existence. Some signals carry a complexity that feels almost intentional. While most cosmic emissions are simple spikes or broad waves, one particular detection presented astronomers with a structure of breathtaking intricacy. It was not a single note but a chord, a precise arrangement of multiple frequencies appearing together like a stark barcode printed against the dark backdrop of space. This pattern emerged from the depths of an interstellar cloud, a sequence of spectral lines so orderly it immediately ignited the most profound of questions. Was this the chemical fingerprint of a giant, unknown molecule, or was it a constructed message? The first and most rigorous task for scientists was to exhaust every possible natural explanation. They turned to the science of spectroscopy, the practice of reading these lines like a cosmic identity card. Every molecule, from simple water to complex organic compounds, emits or absorbs light at specific, unique frequencies. By comparing the mysterious barcode to vast databases of known molecular signatures, researchers hunted for a match. They considered polycyclic aromatic hydrocarbons, large carbon-based molecules that are the soot of the universe. They modeled the behavior of tiny silicate or graphite dust grains, yet the pattern refused to conform. The spacing between the lines was too perfect, the ratios too clean, unlike the messy, overlapping signatures that complex chemistry usually produces in space. This is where the line between natural wonder and potential artifact begins to blur. What if the cloud itself is not the source but the medium? A powerful, artificially generated signal could be projected through the cloud, and the gas would act like a filter, imprinting its own complex absorption pattern onto the original beam. The resulting transmission would carry a double signature, that of the message and the medium, creating a barcode of immense sophistication. Alternatively, could the pattern itself be the message? A deliberate broadcast might use a mathematical sequence, a series of prime numbers perhaps, encoded into the spacing of these spectral lines. It is a concept that feels pulled from science fiction, yet it remains a scientifically valid possibility when confronted with such a structured signal. The painstaking analysis continues, a meticulous process of elimination that has so far failed to find a natural molecule that fits. This leaves us with a haunting and beautiful uncertainty. Are we looking at the largest natural molecule ever discovered, a new branch of cosmic chemistry, or are we staring at the first page of a manuscript we have not yet learned how to read? That search for a cosmic barcode, a structure of almost intelligent design, leads us to a phenomenon where the entire canvas seems to breathe. From the intricate pattern of a single signal, we move to a case where an entire cloud of gas itself appeared to have a heartbeat. Astronomers mapping a relatively small, isolated interstellar cloud noticed something that should have been impossible. The whole structure was pulsing. In radio waves, this vast, dark nebula was swelling and fading with a slow, regular rhythm, like a colossal lung inhaling and exhaling in the vacuum of space. This was not a single point of light blinking, but the entire cloud brightening and dimming in unison, a synchronized dance on a scale so vast it defied any simple explanation. The rhythm was slow, taking years to complete a single cycle, which ruled out the frantic spins of pulsars or the flickering of distant stars. What immense force could make billions of tons of gas and dust beat as one? One leading theory points to a hidden choreographer, a binary star system veiled deep within the cloud's opaque heart. In this scenario, one of the stars could be a highly variable object, perhaps a massive star pulsing in its own right, or one periodically ejecting shells of material. As this star brightens, its intense radiation would heat the surrounding cloud, causing it to glow more brightly in radio frequencies. As the star dims, the cloud would cool and fade. The slow, years-long period of the pulse would then correspond to the orbital dance of these two hidden stars, with one periodically influencing the other's outbursts. This would make the entire cloud a giant screen, projecting the hidden drama happening within. Another, more exotic idea involves the cloud's own magnetic skeleton. These vast clouds are threaded with immense magnetic fields, lines of force that act like the springs in a cosmic mattress. it is possible that the entire cloud was oscillating, ringing like a great bell after being struck by a shockwave from a nearby supernova or a passing gravitational tide. These large-scale magnetic oscillations could, in theory, compress and rarefy the gas in a regular pattern, causing the synchronized pulse we observed. The implications are staggering. If a cloud can pulse like this, it means these seemingly passive structures are dynamic and resonant, capable of behaviors we are only beginning to detect. This slow cosmic heartbeat challenges our very perception of interstellar space, transforming it from a still and silent backdrop into a living, breathing entity. The very pulse of a cosmic heartbeat can simply stop without warning. One of the most perplexing cases began with a signal that seemed to promise a new discovery, a repeating burst of radio waves that was catalogued, studied, and then, without any fanfare, it vanished forever. Unlike the one-time scream from Sagittarius, this source was detected on multiple occasions over a period of several months. Each time it flared to life, it provided more data, allowing astronomers to triangulate its position with increasing precision deep within a specific molecular cloud. They were closing in, preparing for a major announcement when the signal simply ceased. No gradual fade, no final outburst, it was there, and then it was gone, as if a switch had been flipped. For years afterward, the most powerful radio telescopes on Earth were aimed at that precise point in the sky, listening intently for any whisper of its return. They heard only silence. This permanent disappearance creates a unique and profound challenge for science. How can you confirm what something is when it refuses to show itself again? A repeating signal allows for verification, for other observatories to independently detect it and rule out instrumental error. But when that repetition stops, the signal becomes a ghost, a single data point in time that is incredibly difficult to validate or build a theory upon. It leaves behind only questions and a void where an answer should be. So what could cause a seemingly stable source to go permanently dark? One compelling possibility is that we witnessed a transient, one-of-a-kind cosmic event that simply ran its course. Imagine a catastrophic collision between two large bodies, like asteroid-sized chunks of ice and rock within a distant solar system. The immense energy released from such an impact could generate a powerful, repeating radio burst as the debris cloud expands and interacts with magnetic fields. Once the collision is over and the debris settles, the signal would stop, never to be repeated. Another, more unsettling idea is that the source itself was moving. Perhaps it was not a fixed object within the cloud, but something passing through it. An interstellar comet, a rogue planet with a powerful magnetosphere, or even an artificial object on a specific trajectory could have been the origin. As it moved through the dense gas of the cloud, its interactions generated the signal, and once it exited the other side into emptier space, the emissions ceased. The signal did not vanish, we simply lost its trail. This idea transforms our search from looking for fixed points in the sky to hunting for travelers, for needles that move through the cosmic haystack. The silence that followed this promising signal is as eloquent as the signal itself. It teaches us that the cosmos is not just a collection of steady beacons, but a theater of fleeting, dramatic events. Some mysteries announce themselves only once, leaving us to wonder if we were just lucky to have been listening at all, or if we missed our one chance to understand something truly extraordinary. Deep within a cloud thought to be one of the coldest places in the galaxy, a patch of warmth glowed with impossible light. This mystery moves us from the crackle of radio waves to the silent heat of infrared, where a dark nebula was emitting a faint but distinct infrared signature. In the frigid emptiness between stars, where temperatures hover just a few degrees above absolute zero, such a warm glow should not exist. It was the equivalent of finding a lit candle in the heart of a glacier. The immediate question was simple: what could possibly be generating heat in a place dedicated to cosmic cold? One compelling answer lies in the aftermath of a violent, hidden event. Imagine two large bodies, perhaps protoplanets or massive cometary nuclei, colliding in the dark. Such an impact would generate immense, localized heat, vaporizing rock and ice and creating a cloud of warm, fine dust. This dust would then glow in the infrared for centuries before slowly radiating its heat away and fading back into the cold background. We would see the warm aftermath long after the collision itself was over, a ghostly echo of a catastrophe we never witnessed. Another possibility is far more chemical in nature. The signal could be the collective thermal emission from complex organic molecules, the very building blocks of life. Vast quantities of polycyclic aromatic hydrocarbons, which are large carbon-based compounds, can absorb starlight and re-emit it as a diffuse infrared glow. Finding such a strong, localized signature in a cold cloud suggests an incredible concentration of these probiotic materials, a veritable factory of organic chemistry operating in the dark. But this, too, leads to a deeper puzzle. What process is so efficient at manufacturing and concentrating these molecules in a place with seemingly no energy source to power the reactions? Could the cloud itself be hiding a weak, unseen source of radiation, perhaps from a deeply embedded brown dwarf or a rogue planet with active geology that is gently cooking the surrounding gas and dust? This unexplained infrared glow is more than just a thermal anomaly. It is a potential window into the hidden processes that create the ingredients for life itself, all happening in the most unexpected and frozen of places. Motion itself can become a cryptic message. Among the strange signals from interstellar clouds, one stands out not for its power or its pattern, but for the way it moved. This signal carried a Doppler drift, a shift in its frequency, but it was unlike the smooth, predictable slide caused by a planet orbiting a star. Its drift was complex and jerky, a stuttering, non-uniform wobble that implied a source doing far more than just moving in a straight line. It was accelerating or perhaps tumbling end over end through the void. This erratic dance transforms a simple radio pulse into a profound physical puzzle. What kind of object behaves this way? The natural world offers several dramatic possibilities. Imagine a rogue planet, a world untethered from any star, hurtling through an interstellar cloud. If this planet had a strong, tilted magnetic field, its interaction with the cloud's own diffuse gas could generate radio emissions. As the planet tumbled chaotically through space, the orientation of its magnetic field relative to us would change wildly, causing the precise frequency of the signal to wobble in that distinct, non-uniform way. We would be hearing the death cry of a lost world, its magnetic field screaming as it plowed through the galactic medium. Another compelling natural explanation involves a stellar corpse. A neutron star, especially a young, hyperactive one, could be processing. Picture a spinning top as it begins to slow down, its axis tracing a wobbly circle. A processing neutron star would do the same, its lighthouse-like beam of radio waves sweeping across space in an irregular pattern. If that beam passed through a patch of interstellar gas, the resulting signal could carry that complex, accelerating signature. Yet, the very irregularity of the drift pushes us to consider more extraordinary ideas. Could this be the signature of something artificial? A large, derelict spacecraft, its stabilizing systems long dead, would tumble uncontrollably. Any remaining transmitter, powered by dwindling batteries or a dormant reactor, might occasionally emit a signal. As the craft spun and tumbled, the signal's frequency would shift in a wild, unpredictable pattern, a perfect match for the enigma we observed. This is not to claim we found a ghost ship, but to highlight that the signature of a failing, tumbling machine is a scientifically plausible waveform within the vast spectrum of possibilities. The true power of this signal lies in its motion. It forces us to read between the lines of physics, to ask not just what is sending a message, but what that object is doing in the dark. Is it a natural body in its death throes, or is it an artifact of a technology now silent and adrift, tracing a lonely path through the cosmic sea? The chaotic tumble of a drifting object gives way to a signal with a different kind of rhythm, one seemingly tied to the most energetic particles in the universe. From deep within an interstellar cloud, astronomers recorded a faint radio whisper that did something extraordinary. Its strength appeared to pulse in a weak but measurable synchrony with the arrival of cosmic rays, the atomic nuclei that race across the galaxy at nearly the speed of light. This correlation is a profound puzzle, a hint of a conversation between two different languages of the cosmos that, according to our standard models, should not be speaking to each other at all. Cosmic rays are the solitary bullets of space, individual particles carrying immense energy, while radio emissions are the collective hum of vast clouds of gas. To find a link between them suggests a hidden physical process, a secret handshake we never knew existed. So how could a shower of high-energy particles make a whole cloud of gas sing? One speculative idea involves the cosmic rays acting as a catalyst. As these ultra-fast particles slam into the cold, dense hydrogen of the interstellar cloud, they could be ionizing atoms, stripping away their electrons. This would create a soup of charged particles within the cloud. Magnetic fields, which are woven through all such clouds, could then force these newly freed electrons to spiral along their lines of force. This spiraling motion is a fundamental generator of radio waves, a process known as synchrotron radiation. In this scenario, the cosmic rays are not the source of the power but the trigger. They unlock the cloud's latent energy, allowing its own magnetic field to convert that energy into the anomalous radio signal we detect. The more cosmic rays hit the cloud, the more electrons are freed to spiral, and the brighter the radio glow becomes. This creates that subtle correlation, a faint echo of the cosmic ray flux. Another, more exotic possibility dives into the quantum world. It postulates that the cosmic rays are interacting not just with the atoms, but with the cloud's dark matter content. If dark matter particles accumulate within these dense clouds, as some theories suggest, the passage of a high-energy cosmic ray could occasionally collide with one, annihilating both and releasing a burst of energy that manifests as a pulse of radio waves. This would be an indirect signal of dark matter itself, a ghostly fingerprint revealed only when stirred by the passage of a cosmic bullet. The implications of this correlation reach far beyond a single cloud. If proven true, it would mean these vast, dark structures are not passive backdrops, but active participants in the galaxy's energy cycle. They are cosmic instruments, and the rain of high-energy particles is a bow that plays upon them, producing a faint, mysterious music we are only just learning to hear. This mathematical elegance stands in stark contrast to the chaotic drift of tumbling objects. Another signal, emerging from the quiet of a dust-shrouded cloud, presented a structure of almost impossible beauty. When astronomers broke it down into its fundamental components, they found its amplitude and phase were locked in a precise, symmetrical dance. The amplitude, which is the signal's strength, rose and fell in a mirror image pattern. Simultaneously, its phase, the specific timing of the radio waves, shifted in a perfectly complementary rhythm. This kind of coordinated, bilateral symmetry is a hallmark of intelligent design in human engineering, found in everything from the filtered tones of a modem to the structured pulses of radar. In the natural cosmos, such pristine order is extraordinarily rare. Turbulence, magnetic chaos, and random thermal motions almost always introduce imperfections and asymmetries into astrophysical signals. This one was different. It was a perfectly balanced equation written in radio light. To quantify just how strange this was, scientists subjected the signal to a battery of rigorous statistical tests. They calculated the probability that a random, natural process could generate such a symmetrical waveform. They used algorithms designed to search for hidden correlations and patterns within noise, testing against thousands of simulated cosmic events. The results were unequivocal. The likelihood of this symmetry arising by pure chance was astronomically low, a tiny fraction of a percent. This forced a difficult question. Had they discovered a new, unknown natural phenomenon that creates order from chaos with flawless precision, or were they looking at something that was engineered? A naturally occurring maser, for instance, can produce strong signals, but its output is invariably messy, shaped by the unstable environment that powers it. This signal was clean, its symmetry suggesting a designed filtering or modulation process. It is the difference between the sound of wind whistling randomly through a canyon and the precise, structured note of a flute. The signal's symmetry does not prove it is artificial, but it elevates it to a category of its own. It becomes an object of intense fascination, a cosmic artifact that challenges our very definitions of natural and design. Is it the signature of a universal physics we have not yet grasped? Or is it a signature in the most literal sense, a carefully constructed imprint left by a consciousness that understands the language of mathematics as well as we do? Even the quietest corners of the cosmos can sometimes shout. Our next signal emerged from a region of an interstellar cloud that was, by all accounts, dead. This was not a vibrant stellar nursery or a chaotic region churned by hidden objects. It was a cold, quiescent patch of gas, a place where temperatures plunged to just a few degrees above absolute zero, and where molecules should be almost dormant. According to every established model of astrophysics, this zone was simply too cold and too calm to produce any significant radio emission. The atoms and molecules there lacked the energy to get excited, both in the literal and figurative sense. To produce the kind of signal detected, they would need a source of energy, a pump, to kick them into a higher energy state so they could release that energy as light. But in this dead zone, no such pump was visible. There was no nearby star to provide radiation, no shockwave from a supernova, no stirring from a passing gravitational force. It was the cosmic equivalent of a flashlight turning on inside a sealed, unpowered box. So what flipped the switch? One radical possibility is that our understanding of the minimum energy required to excite atoms is fundamentally flawed. We base our models on laboratory experiments and well-understood quantum mechanics, but what if the extreme conditions within these clouds, the near-total vacuum and the presence of complex, layered magnetic fields allow for a lower energy threshold? Perhaps a process we have never observed on Earth, a form of quantum tunneling or a collective resonance across vast numbers of atoms, enables them to become excited with only the faintest whisper of energy. Another, more startling idea is that the energy is not coming from within the cloud at all, but from something beyond it. Could an invisible source, like a distant gamma ray burst or a beam of concentrated energy from a black hole's jet, have swept across this patch of gas like a searchlight? The signal we detected would then be a momentary flash, the ghostly afterglow of a torrent of energy that passed through and vanished, leaving the cloud once again in darkness. This signal forces a humbling realization. Our maps of the cosmos are not just missing landmarks, we might be misreading the very ground rules of how light is created in the void. Is this a sign that the darkness between the stars is not nearly as dormant as we believe, or did we just catch a fleeting reflection from a catastrophe that happened light years away? A perfect cosmic metronome can hide the strangest of truths. From a seemingly ordinary interstellar cloud, astronomers detected a signal that ticked with breathtaking regularity, a rapid pulse that repeated every few milliseconds with a precision that rivaled our best atomic clocks. It was the unmistakable signature of a pulsar, the spinning core of a dead star. Yet, as they continued to observe this celestial timepiece, they noticed something deeply wrong. A pulsar is a cosmic spinner slowly running out of energy. Its rapid spin should gradually, measurably slow down over time, a phenomenon called spin down. This signal, however, refused to slow. Its period remained locked, unwavering over years of observation, as if powered by some endless, unknown source of energy. This defiance of a fundamental law of physics transformed a familiar object into a profound anomaly. If it is not a pulsar slowing down, then what is it? One compelling theory points to the hidden vibrations of an entirely different class of star. Imagine a massive, unstable star, many times larger than our Sun, quivering and oscillating like a colossal ringing bell. These are stellar vibrations, a field of study called astroseismology. Under the right conditions, these powerful, resonant quakes could theoretically modulate a star's magnetic field or its stellar wind, creating a regular, pulsing radio signal that mimics a pulsar's clockwork. The key difference is that the pulse comes from the star's oscillation, not its spin, and such a vibration could potentially remain stable for a very long time without the predictable spin down of a neutron star. This would mean we are not looking at a stellar corpse, but at a living, breathing giant, its internal rhythms broadcast across the galaxy. An even more exotic possibility is that we have found a new type of compact object altogether, something that exists in a theoretical gray zone between a neutron star and a black hole. A quark star, for instance, a hypothetical object where matter is crushed even further than in a neutron star, could have radically different physical properties, potentially allowing it to spin without the same energy loss. Or perhaps it is a magnetar, a neutron star with an impossibly powerful magnetic field, whose intense magnetic forces are somehow counteracting the spin down, effectively putting a brake on the braking process itself. This perfectly regular, unwavering pulse forces us to reconsider the very definition of a clock in the cosmos. Is it the dying spin of a collapsed star, or could it be the steady, resonant heartbeat of something entirely new, an object whose fundamental nature challenges our catalogue of the stars? A piercing shriek erupted from one of the darkest and most isolated nurseries in the cosmos, a Bok globule. These are not the grand, glowing clouds of Orion, but small, dense cocoons of gas and dust so thick they appear as black holes against the starry background. They are the wombs for single, nascent stars, places of such profound quiet and cold that the birth of a sun within is meant to be a slow, gentle collapse. Yet from this particular pocket of darkness came a radio burst of staggering power, a violent, short-duration explosion that contradicted the very nature of its serene environment. What could possibly shatter the silence of a stellar cradle with such force? The leading theory is as dramatic as the signal itself, a stellar miscarriage. Deep within the globule, a protostar, a baby star still gathering mass from its surrounding cloud, may have experienced a catastrophic accretion event. Imagine a vast river of gas flowing smoothly onto the young star's surface, suddenly dammed by its own powerful magnetic fields. The material would build up, a colossal weight pressing down until the magnetic barrier catastrophically failed. In an instant, a pent-up ocean of gas would come crashing down onto the protostar's surface, releasing a titanic flash of energy. This event, known as an accretion burst, is a stellar tantrum of unbelievable proportions, a birth spasm that would flood the surrounding void with a powerful, fleeting radio scream. But the sheer intensity of this burst pushes this idea to its limits. Could a single young star generate that much power? This question opens the door to a more speculative and thrilling possibility. What if we are not witnessing the birth of a star, but the death of a planet? In the chaotic early environment around a protostar, planetary formation is a violent game of collisions. It is conceivable that a fledgling gas giant, a Jupiter in its infancy, spiraled too close to its parent star and was torn apart by immense gravitational tides. The destruction of such a massive world would release an apocalyptic surge of energy, a final, brilliant flash as the planet was shredded and consumed. This burst would be a one-time event, a signal that marks not a beginning, but a catastrophic end in the hidden dark of a stellar nursery. The echo from that Bok globule forces us to reconsider the tranquility of star birth. It suggests that within these dark wombs, the process is not always a steady, peaceful gathering of light, but can be a violent, chaotic drama where worlds are unmade and stars scream their arrival into the cold, uncaring void. Light can carry a hidden signature in its very orientation. Our next signal arrived with its electromagnetic waves all marching in lockstep, a property scientists call high polarization. This is not a random jumble of vibrations, but a coordinated army of light waves oscillating in a single, preferred direction. Such perfect order does not happen by accident in the chaos of space. It is the unmistakable fingerprint of a powerful and incredibly structured magnetic field. Think of space as a stormy ocean with interstellar clouds as the churning waves. Within that turbulence, you would expect magnetic fields to be tangled and messy, a knotted snarl of forces pointing in every direction. A signal generated in such an environment would be unpolarized, its waves scrambled and unaligned. But this signal was different. Its high polarization tells us that at its source, the magnetic field is not a tangled mess. It is more like the orderly lines of force surrounding a simple bar magnet, straight, strong, and uniform over a vast area. This presents a monumental puzzle. How does such a perfectly ordered magnetic field arise and persist within the violent, turbulent interior of a gas cloud? The natural processes we know of should shred this kind of order. The sheer kinetic energy of gas swirling and colliding at supersonic speeds should twist and tangle any large-scale magnetic field, destroying the precise alignment we observe. One radical possibility is that the source itself is generating this immense field. Imagine a rapidly spinning, super-dense object like a neutron star, whose spin is powering a dynamo effect, creating a magnetic field of almost unimaginable intensity that simply overpowers the local chaos. This object would act as a cosmic anchor, imposing its own magnetic order on the surrounding cloud. But the strength required is staggering, pushing the very limits of what we believe is physically possible for such an object. Another, more subtle idea is that we are witnessing a magnetic fossil. Perhaps in the distant past, a shockwave from a supernova or the focused jet from a black hole compressed and stretched the cloud's magnetic field, ironing out all the kinks and leaving behind these perfectly straight lines frozen in time. The cloud would then be a museum displaying a relic of an ancient cosmic catastrophe. The polarization of this signal is a quiet but insistent clue. It suggests that hidden within these apparent clouds of chaos are islands of perfect order, realms where magnetic forces have tamed the storm, and we are left to wonder what powerful object or what forgotten event could possibly be the architect of such a perfect cosmic symmetry. A faint, persistent whisper from a seemingly ordinary gas cloud suddenly became the center of a major cosmic controversy. This signal was not powerful or strange on its own, but it had one extraordinary feature: its location. It emanated from the exact same patch of sky where astronomers had previously detected a fast radio burst, one of the universe's most powerful and mysterious explosions. Fast radio bursts, or FRB, are millisecond-long blasts of radio energy that can outshine entire galaxies, and they typically vanish without a trace. This one, however, may have left a ghost behind. The idea that the faint signal could be a lingering afterglow of the colossal FRB challenges everything we think we know about these events. The standard model suggests FRBs are one-off cataclysms, like the final collapse of a star or the merger of two neutron stars, events that are brilliant, final, and leave nothing but expanding debris. A persistent afterglow simply does not fit. It implies the source of the burst survived the explosion and continued to emit energy, or that the burst itself triggered a longer-lasting process within the cloud. So what could this faint signal be? One possibility is that the FRB was not a death cry but a birth scream. Perhaps the intense energy of the burst illuminated a nearby, otherwise invisible object, like a young, highly magnetized neutron star. This neutron star, now revealed, continues to pump energy into the surrounding gas cloud, causing it to glow faintly in radio waves long after the initial flash. We would be seeing the echo of that powerful birth, a cosmic newborn's cradle still shimmering from the trauma of its arrival. Another, more radical, theory suggests the FRB itself was a different kind of event altogether. Could it have been a directed energy burst so powerful that it superheated a pathway through the interstellar cloud, ionizing the gas and leaving behind a temporary radio-emitting plasma filament? The faint signal we detect would then be the slow, cooling aftermath of that incredible energy discharge, a scar etched across the cloud that is gradually fading. This single, faint whisper forces us to reconsider the nature of cosmic violence. Are fast radio bursts always the final, destructive end of something? Or could they sometimes be the dramatic beginning of a new phase, leaving behind a quiet but telling signature for those patient enough to listen? A cosmic forest grows in the darkness between the stars, within the radio spectrum of a single, unassuming gas cloud. Astronomers found not one signal but hundreds. This dense, tangled thicket of emission lines is known as a molecular line forest, a place where the spikes and dips on a graph form a wilderness of unidentified chemical signatures. Each line is a barcode for a specific molecule, a unique identifier based on the way it vibrates and rotates. In this particular forest, scientists could identify many of the trees, spotting the familiar signatures of common molecules like carbon monoxide and ammonia. But scattered throughout were lines that refused to be catalogued, spectral ghosts that corresponded to no known substance in any laboratory database on Earth. This is the cutting edge of astrochemistry, a hunt for new molecules in the vast laboratory of space. The very existence of these unknown lines tells us that the chemistry occurring in these cold, dark clouds is far more complex than we ever dreamed. We are finding that these seemingly simple environments are capable of building large, intricate molecules, some of which may be the direct precursors to the building blocks of life. So what could these mystery molecules be? The prime suspects are complex organic molecules, carbon-based structures larger and more elaborate than any we have seen before. On Earth, we synthesize such molecules in labs, but in space, they could be forming on the surfaces of tiny dust grains, where atoms meet and link together in the cold vacuum over millions of years. One tantalizing possibility is that we are seeing the spectral signature of a molecule like an amino acid, a fundamental component of proteins, or it could be a sugar or a component of DNA. The problem is one of scale and confirmation. The signals are faint, and the number of possible molecular structures is astronomical. How do you find the one specific key that fits a lock you have never seen? This requires a painstaking process of elimination and prediction. Chemists use powerful computers to model the quantum behavior of hypothetical large molecules, calculating what their spectral barcode would look like. They then compare these theoretical fingerprints to the unknown lines in the cosmic forest. It is a monumental task, like trying to identify a single person in a city of millions by only their shadow. Each unknown line that gets identified expands our understanding of the universe's chemical potential. It reveals that the pathways to complexity are written into the fabric of interstellar space, that the raw ingredients for life are not just possible, but are being manufactured in abundance in the cold, dark nurseries between the stars. This molecular forest is more than a catalogue of chemicals. It is a living library of cosmic recipes, and we have only just begun to learn how to read its pages. Even the most stable cosmic broadcasts can be haunted by a ghostly rhythm. Deep within the data of a steady interstellar signal, astronomers noticed a faint, repeating pattern of modulation. The signal's strength would dip by a tiny, precise percentage, hold for a while, and then return to its full intensity, only to repeat the cycle again much later. This was not the chaotic flicker of a turbulent cloud, but the clean, periodic signature of an eclipse, as if something were passing in front of the source on a predictable orbit. The immediate and astounding implication was that the signal's origin might be locked in a gravitational dance with another unseen body, a planet orbiting within the cloud itself. The concept of a planet forming in the dark, open expanse of an interstellar cloud far from any star challenges the very definition of a world. We think of planets as children of stars, born in the disks of dust and gas that swirl around a newborn sun. But a rogue planet, a world torn from its native solar system and sent adrift, could theoretically be captured by the gentle gravity of a dense cloud. For this scenario to work, the cloud would need a compact, powerful signal source at its center, perhaps a pulsar or a maser acting as the lighthouse. The orbiting rogue planet would then be the ship passing in front of the beam, its silhouette causing that regular, faint dimming we detect. To confirm such a thing is a monumental challenge. The first hurdle is the sheer distance and scale. The orbit of such a planet would be immense, taking years or even decades to complete a single cycle. Catching just a few dips in the signal over a human lifetime is not enough to firmly establish a pattern. It requires patience across generations. Furthermore, the planet itself would be utterly invisible to our telescopes, a dark speck against a dark background, its presence inferred only by the shadow it casts on a radio beam. Scientists must rule out every other possibility, such as a slow pulsation of the source itself or a passing clump of denser gas within the cloud. They use complex statistical models to calculate the probability that the observed dips are just random noise, and in this case, the odds were overwhelmingly against coincidence. The modulation was real. If this interpretation is correct, it opens a window into a profoundly alien planetary environment. This would not be a world warmed by a sun, but a frozen, nomadic sphere drifting through a perpetual, starless night. Its only light the constant, silent flash of a cosmic lighthouse it periodically obscures. The discovery hints at an unseen population of lonely worlds and suggests that even the most isolated signals in the void might not be alone. Buried within a mountain of old data, a ghost was waiting. This story begins not with a new discovery at a telescope, but with a graduate student staring at a computer screen, sifting through decades-old observations of a quiet interstellar cloud. The initial data, recorded in the 1990s, had been flagged and filed away. A faint, anomalous spike was noted by the original team, but it was dismissed as radio frequency interference, a whisper from a passing satellite or a glitch in the electronics. It was considered digital static, meaningless noise to be filtered out and forgotten. But years later, armed with more powerful computers and new analytical techniques, that student decided to look again. The process of data archaeology, of digging through astronomy's digital archives, is like panning for gold in a river others have already abandoned. You are looking for the tiny, overlooked nugget everyone else missed. The student applied modern algorithms designed to find weak, recurring patterns, and that is when the ghost began to take shape. The faint signal was not random. It had a coherent structure, a specific frequency profile that matched what you would expect from a source deep within the cloud, not from a nearby piece of human technology. The more they cleaned the data, the more real it became. This was not an artifact, it was a cosmic whisper that had been hiding in plain sight for 30 years. Its resurrection forces a humbling question. How many other genuine signals have we thrown away because we assumed they were just noise? Our own technological arrogance, our belief that we can easily distinguish our own chatter from the voice of the cosmos, may be the very filter blinding us to the truth. Every archive of old data is now a potential treasure map, and the most important discoveries might not be waiting in the future of our telescopes, but in the forgotten past of our own hard drives. Sometimes the most telling signal is not what is present, but what is missing. Deep within the radio spectrum of a distant interstellar cloud, astronomers found a void, a narrow and specific frequency that had been cleanly carved out of the background light. This is an absorption feature, a cosmic shadow. It occurs when light from a background source, like a distant quasar or a bright star, passes through a cloud of gas on its way to us. The atoms and molecules within that cloud act like a filter, absorbing light at their own unique frequencies and leaving behind these dark notches in the spectrum. Each notch is a barcode, a direct identifier of the substance that created it. In this case, however, the barcode was for a product that was not on any of our shelves. The absorption dip was at a frequency that did not correspond to any known atom or molecule. Something unknown and mysterious within that cloud was hungrily consuming that precise slice of energy, and we have no idea what it is. The search for the culprit is a meticulous process of elimination. Scientists first run through the entire catalog of known cosmic chemicals, from simple hydrogen to complex organic molecules. They check for isotopes, heavier versions of common atoms that absorb light at slightly different frequencies. They model the behavior of molecules under the extreme cold of interstellar space, seeing if their signatures might shift in unexpected ways. So far, every candidate has been ruled out. This leaves two profound possibilities. The first is that we have discovered a new, entirely unknown molecule. This would not be a simple compound, but something large and complex, with a structure that allows it to vibrate or rotate in a way that absorbs this very specific radio energy. Finding it would be a monumental breakthrough in astrochemistry, proving that the chemical diversity of the universe is far richer than we ever imagined. The second possibility is more fundamental. Could this be the signature of dark matter itself? We know dark matter must exist due to its gravitational effects, but we have never directly detected it or understood its nature. Some theories suggest certain types of dark matter particles could interact very weakly with regular light, absorbing photons at a specific characteristic frequency. If that is the case, then this unexplained dip is not just a shadow from a new molecule, but the first ghostly imprint of the universe's most elusive substance. This single, silent gap in a beam of light is more than an absence. It is a question mark written in negative space, a clue that the cloud is hiding something far more significant than just gas and dust. A primary radio pulse shot out from a dark nebula, sharp and solitary. Then, seconds later, a perfect, fainter copy of the same signal arrived. This was not a random burst, but a deliberate echo, a cosmic whisper repeating its own message. The delay between the two was precise, a fixed interval that ruled out a simple second source or a random coincidence. Something in the void had taken that original signal, held it for a moment, and bounced it back to us. To understand this, picture shouting across a vast canyon. Your voice travels directly to a listener on the other side, but a moment later, you hear your own words reflected back from the canyon wall. The echo in space works on a similar principle, but the scales are almost incomprehensible. The first and most straightforward explanation is a cosmic mirror, a distant, dense sheet of interstellar dust and gas. The initial signal traveled directly to Earth, while a portion of it continued onward, striking this far-off dust cloud and reflecting back toward us. The time delay is the extra distance the reflected signal had to travel. The problem is the mirror would need to be almost perfectly flat and aligned to create such a clean, undistorted copy. In the turbulent, chaotic interior of a gas cloud, such perfect reflective surfaces are thought to be incredibly rare. This leads to a second, more mind-bending possibility: gravitational lensing. A massive, invisible object like a rogue black hole or a dense knot of dark matter could have drifted between us and the source. Its immense gravity would warp the fabric of space-time, acting like a giant lens. One path of the signal would come directly to us, while another path would bend around the object, taking a slightly longer route and arriving moments later as the echo. This would not be a reflection, but a cosmic mirage, a single event whose light has been split by an invisible gravitational lens. The implications of this are profound. If it is a dust cloud, it reveals hidden structures within the interstellar medium, vast, smooth walls we never knew existed. If it is gravitational lensing, it gives us a new way to detect the universe's dark, unseen mass, mapping the invisible architecture of the galaxy by the echoes it creates. This signal does not just speak once, it answers its own call, and in that brief, ghostly repetition, it shows us that space itself is filled with unseen mirrors and hidden lenses. The silent gaps and ghostly echoes from interstellar clouds challenge our perception of what fills the void, but one signal pushes this mystery to its absolute limit. This anomaly did not just present an unknown chemical signature, it displayed physical properties that seemed to contradict the very nature of normal matter. Its intensity, its spread across the radio spectrum, and the way it dissipated were all inconsistent with the behavior of protons, neutrons, and electrons, the baryonic matter that makes up every star, planet, and gas cloud we have ever seen. This inconsistency is what leads some scientists to a breathtaking, albeit speculative, hypothesis. Could this be the first indirect signal from a cloud of dark matter? We know dark matter must exist. Its gravitational pull is the only thing that keeps galaxies from flying apart, yet it emits no light and has never been directly detected. It is the universe's most dominant and most elusive ghost. The theory suggests that within these vast interstellar clouds, dark matter particles might accumulate, drawn together by their own gravity. If two of these particles were to collide, they could annihilate each other in a flash of energy, converting their mass directly into other forms, including radio waves. Alternatively, a single, unstable dark matter particle could spontaneously decay, releasing its energy over time. In either scenario, the resulting signal would carry a unique fingerprint, a specific spread of energy that does not match any known astrophysical process involving regular matter. This is not a claim of discovery, but a frontier of possibility. The signal acts as a tantalizing clue, a shadow on the cave wall that hints at the shape of something profound. Proving it, however, is a monumental task. How do you confirm the existence of something defined by its invisibility? The search now focuses on prediction and correlation. If this signal truly comes from dark matter, then similar signals should be detected from other regions with high predicted dark matter density, like the centers of galaxies or the edges of galaxy clusters. It is a cosmic treasure hunt guided by the map of gravity itself. This signal, more than any other, blurs the line between established physics and the edges of our understanding. It asks us to consider that the answers to the universe's biggest mysteries may not be written in the light of the stars, but in the faint, anomalous whispers emerging from the dark. A single event can sometimes speak in many languages at once. Signal number 24 arrived not as a solitary whisper on one frequency, but as a coordinated shout across the entire electromagnetic spectrum. From the heart of an interstellar cloud, a powerful surge of energy was recorded nearly simultaneously as a radio wave burst, a flicker of visible light, and a flash of penetrating X-rays. This multi-wavelength harmony is a rare and baffling occurrence in the cosmos. Natural events tend to be messy and inefficient, releasing their energy in one primary form. A supernova, for instance, might blast out most of its energy in visible light and X-rays, with radio emission as a secondary, slower aftereffect. For one brief event to produce such a clean, synchronized output across these vastly different energy bands suggests a source of incredible efficiency and focus. It points to a single, catastrophic release of energy that was instantly converted into these different forms of light. So what kind of cosmic engine could possibly achieve such a feat? One compelling candidate is a magnetar flare. A magnetar is a type of neutron star with a magnetic field so unimaginably powerful it could strip the information from a credit card from halfway across the solar system. If such an object hidden within the gas cloud experienced a starquake, a sudden cracking of its rigid crust, it could release a colossal wave of energy. This event would flood its surroundings with high-energy particles, generating X-rays from the immediate shock, visible light from the heated gas, and radio waves from electrons spiraling in the intense magnetic field. The entire sequence would be virtually instantaneous, creating the precise multi-wavelength signature we observed. Yet, the sheer coordination required pushes even this explanation to its limits. Another, more speculative possibility involves an engineered source. Consider the principles behind a focused energy weapon or a powerful communications beacon. Such technology would be designed for maximum efficiency, to convert raw power into a directed emission across multiple channels with minimal loss. A naturally occurring event is like a stick of dynamite exploding, a chaotic release in all directions. What we witnessed was more like a laser, a coordinated discharge. This does not prove an artificial origin, but it does set a very high bar for any natural explanation to meet. The implications of this coordinated signal ripple outward. If it was a magnetar, it means these incredibly dense magnetic monsters can form and hide within seemingly peaceful gas clouds, their presence only revealed by their occasional universe-shaking tantrums. If it was something else, something even more exotic or directed, then we are looking at a fundamental new class of astrophysical event. This one moment of harmony across the spectrum shows us that the cosmos is capable of a precision we are only just beginning to measure, a fleeting glimpse of a perfect, energetic choreography in the dark. This final signal is the ultimate cosmic paradox. It arrived with the perfect symmetry of a designed message, pulsed with the steady rhythm of a dead star, drifted in frequency like a tumbling object, and shone brightly across multiple wavelengths all at once. Every anomalous feature we have encountered seems to converge here, creating a chimera of a signal that defies every label in our scientific library. It is a reminder that for every mystery we catalog, the universe seems to craft another that shatters the categories we create. What natural process could possibly explain a source that behaves like a stable clock, a chaotic tumbler, a structured broadcaster, and a multi-spectral flare simultaneously? The very attempt to force it into a single box highlights the limitations of our current understanding. Perhaps we are not looking at one object, but at the complex interaction of several hidden phenomena within the cloud, a cosmic orchestra whose individual instruments we cannot yet distinguish. Or maybe this signal is a glimpse of a unified physics, a deeper set of rules where what we see as separate anomalies are merely different facets of a single, extraordinary process. This final entry in our catalog does not provide answers. Instead, it stands as a monument to our ignorance, a brilliant and baffling beacon that ensures the greatest discoveries in astrophysics are still waiting, hidden in the dark, for the next generation of listeners. 25 signals, each a unique key turning a different lock in our understanding of the cosmos. From the solitary scream in Sagittarius to the coordinated multi-wavelength shout, this catalogue of anomalies does not present a single, unified mystery, but a chorus of contradictions. Each one challenges a different pillar of our knowledge. The perfect symmetry defies our models of natural chaos. The impossible propagation through the hydrogen fog rewrites our maps of interstellar space, and the ghostly correlation with cosmic rays hints at a hidden conversation between matter and energy. There is no grand, single theory that can explain them all, and that is the most profound lesson they offer. The universe is not merely hiding one big secret from us, it is whispering 1,000 smaller ones, each proving that our current science is a magnificent but incomplete map of reality. So we turn this final question over to you. As you look up at the night sky, which of these cosmic whispers captures your imagination the most? Was it the patient, repeating heartbeat of the Orion cloud, the structured barcode that looked almost like a message, or the faint thermal glow from a place of impossible cold? Share your thoughts and let your own curiosity be the next instrument pointed at the void. For the greatest discoveries are not always about finding the answers, but about learning to ask better questions of the dark, silent clouds drifting between the stars.